In this video, we're going to look at to see if a function is a product, a sum, or a quotient. In other words, we could use the product rule, our sum and difference rules, or quotient rule to find the derivative. If it's a composition, what we're going to do is write it so that we know exactly what f and g are, such that the function is f of g of x. Otherwise, we'll take the derivative. So in A here, we have h of x equals tangent of 2 to the x. That's going to be a composition of functions. So if we wanted to write that as a composition, in other words, as f of g of x, with g of x being the inside function, then we would have f of x is the outside function, which would be tangent of x, and g of x is the inside function, which is 2 to the x. We're going to find something called the quotient rule, called the chain rule, that'll help us take the derivative of compositions. But right now, we're just identifying whether or not it's a composition. In B, we have a function that is actually a product. So this we can find the derivative of. We'll call it p prime of x, and this is just a product rule. So I'm going to hold the first part, 2 to the x constant, times the derivative of tangent x, which is secant squared of x, plus, now we're going to hold the second part constant, tangent of x, times the derivative of the first part, derivative of an exponential, is 2 to the x times the natural log of the base. So no special rules there, it's just our product rule. R of x. This we could look at two ways. First, let's look at it as a product, because we could write it as tangent of x times tangent of x, which means we would use a product rule to find r prime of x. So hold the first part constant, so tangent of x times the derivative of tangent, which is secant squared of x, plus, now we're going to hold the second part constant, which is going to look a lot like the first, tangent of x, times the derivative of tangent of x, which is secant squared of x. So we could simplify that into 2 tangent of x times secant squared of x. So we can find the derivative with the product rule. We could also look at it as a composition. We're using the inside function. We're calling it g still. G of x would be the inside function, which would be tangent of x. Therefore, the outside function f would just be x squared, because what's happening is tangent is getting put in as the input and being squared. M of x is a composition. So, in this case, the inside function, again in this one, is tangent of x. So sometimes it's easier to identify the inside function first. And then you got to imagine, once you identify that inside function, imagine an x being in its place to get the outside function. So f of x would be e to the x. Down here in E, we don't even need product or quotient rule, but we might want to rewrite this as x to the 1/2, so we can use our power rule, plus tangent of x. So the derivative of w, called w prime of x, is going to be 1/2 x to the minus 1/2 plus the derivative of tangent, which is secant squared x. We can just do that one piece by piece. If we want to put it back in terms of radical, 1/2 square root of x plus secant squared x. One more. Had a little mistake here. My apologies. Once again, this is going to be a composition. I can see that my inside function, remember we're writing these compositions as f of g of x. It's going to be really important going forward as you learn the chain rule. G of x equals tangent of x, so that's the inside, which means, remember, we replace that with an x to get what the outside will look like. F of x equals square root of x, or x to the 1/2. So being able to break that into a composition is going to help going forward as we learn the chain rule.